Hello, Tom from Every Step Calculus, everystepphysics.com. Thanks for looking at my video here. I'm going to show you how my programs work on this one. This is a square root of x graphing problem, and we're going to revolve this square root of x given the 4 and the 9 limits on the x-axis around the x-axis, and we're going to find the area of the surface of this imaginary problem. Let's do it. Index 8 to get to my menu. Hey, by the way, can you go to the right over here and subscribe to my if you want, to see other videos. Just want to remind you of that. Let's do index 8 here. Index 8 to get to my main menu. Here's the main menu. We're going to go up with this cloverleaf cursor here to get down to the bottom of the alphabet and go up here to surface area, which is all menu driven in my programs. No fooling around, no teaching. Wouldn't waste my time teaching this crap. If you've seen my other videos, you know I'm totally against teaching calculus in colleges. I'll never win that case because it's so useless for anybody in a useful way. Not one calculation has been used for anything important. Just a series of puzzles like Sudoku or crossword puzzles that we're supposed to solve in college for this course, And so anyways, surface area, and we're going to choose around the x-axis. Now notice that you can go around the y-axis too. And we're going to, here's the formula, 2 pi times the integral of y ds. Okay, the ds is the arc length formula here, square root of 1 plus y prime, the derivative of y squared with respect to x. Write this on your paper so you look like a genius and during your test, okay? Enter f of x. Okay, let's do it. You have to press alpha first, second, time sign is the square root sign, second is the second register here. All these little characters above the numbers are what you're going to now when you press the second register. And we're going to put in square root of x, close off the parentheses, and the limits are going to be alpha 4, alpha 9. By the way, this is a Patrickjmt problem that he put up as an example, and I wanted to show you that I can do this in my programs too. And you don't have to learn it, you can just use my programs for the rest of your life and pass any calculus test. Patrickjmt is about the best teacher on calculus that I found. So he has something like 900 subscribers, 900,000 subscribers, so he's a good one to follow, okay? But why not buy my programs, and you can do it in your calculator, bring it to a test, bring it to your homework, have it in your school bag or your purse, and for the rest of your life be able to solve calculus problems, even when you in the future have grandkids or kids of your own taking college calculus or business calculus if your spouse tends to do that. Anyways, I show you what you've entered. Square root of x over the limits of 4 and 9. A and b is 4, 9, okay? And we're going to find the derivative of y prime here, 1 over 2 times square root of x. and we substitute in these for the integral. Substitute the variables in here. And now we're going to find this, what the 1 plus y prime squared is. Substitute this in, and we square it. Turns out to be 1 divided by 4x. We find a common denominator, which is 4x plus 1 divided by 4x. Take the square root of that. We got square root of 4x plus 1 divided by 2 times square root of x, okay? So the integral then becomes 2 pi times the integral of square root of x times square root of 4x plus 1 divided by 2 times the square root of x dx. Pretty easy. You could do this without my program. You can do this by memory, can't you? Take the constant out, 2 times 1/2, okay? And the integral becomes, the x's cancel too, square root of x's cancel, pi over 4 and 9, integral of square root of 4x plus 1 dx. Use substitution. All these problems are use substitution. They make them work out to that. It's another pathetic thing about them. They're all set-up problems, not reality whatsoever. You're not going to go to Home Depot and find the gallons of paint to go around this imaginary surface here, because you got the square root, you got the area, surface area of this imaginary image here. And the integral becomes this. You write this all on your paper, u to the 1/2, okay? The square root of u is u to the 1/2. Remember, that's always changed in calculus. Always remember that, we can change that. Constant comes out, 1/4 out here. We change the limits of integration. You always got to do that with use substitution. Don't think you don't have to do it. You have to do it at 4, and then you substitute it in what you've found to be u, and equals 17 or 37. Integral becomes 1/4 pi over these limits now. Now we're going to integrate it. Turns out to be 2/3 u to the 3/2. Remember, this was u to the 1/2. Okay, you add 1 to that, which is 2/2. Turn out to be 3/2 up here, and then you divide that by that exponent, and then when you multiply it, you invert and multiply. When you divide by 3/2, okay, it becomes 2/3. Here it is here. All right. And then we do the calculations. Turns out to be 81.1 square units. Pretty neat, huh? Go to my site, buy my programs, and pass calculus. Also, I'll help you if you need it. You can call me. I will give you my phone number. You can call me. I'll help you with calculus. You can send me tests, and I'll make sure that you know how to use my programs and problems, for the problems that you have. Show you how to do that. So, a great deal. All right. So, purchase my programs and pass calculus. Have a good one.